In mathematics, a function is a rule or relationship that assigns each element from one set, called the domain, to a unique element in another set, called the codomain. It describes how the elements of the domain are related to the elements of the codomain. A function takes inputs, processes them, and produces corresponding outputs. The key features of a function are: domain, the set of all possible input values for the function. It defines where the function is valid. Codomain, the set of all possible output values for the function. It indicates the possible range of the function's output. Rule, the specific relationship or operation that defines how each input is mapped to its corresponding output. Unique mapping. Each element in the domain must have one and only one element in the codomain associated with it. No input can have multiple outputs. Notation. Functions are typically represented using symbols. If f is a function, we often write it as f, x, or f, x right pointing arrow y, where x is the input from the domain, f, x is the output from the codomain, and the arrow right pointing arrow signifies the mapping. For example, let's consider a simple function, f, x equals 2x. Here, the domain can be any real number, and the codomain can also be any real number. For each input value x, the function will double it to produce the corresponding output value f, x. Another function, g, x, equals x squared. In this case, the domain can be any real number, and the codomain is also any real number. The function takes the input x, squares it, multiplies it by itself, and gives the result as the output. Functions are fundamental in mathematics and have various applications in different fields, including physics, engineering, economics, and computer science. They provide a way to model and understand relationships between variables and help us analyze and solve problems in a structured and systematic manner. Functions can be classified into different types based on their properties and characteristics. Here are some common types of functions with examples. Linear function. 1. Definition. A linear function is a function where the highest power of the variable is 1. 1. It represents a straight line when graphed. 2. Example, f, x, equals 2x plus 3 is a linear function. 2. The variable x has a power of 1, and the function produces a straight line on the graph. Quadratic function. 1. Definition. A quadratic function is a function where the highest power of the variable is 2. 1. It represents a parabola when graphed. 2. Example, g, x, equals x squared 4x plus 3 is a quadratic function. 2. The variable x has a power of 2, and the graph is a parabola. Exponential function. 1. Definition. An exponential function is a function where the variable is in the exponent. 2. Example, h, x, equals 2 caret x is an exponential function. 2. As x increases, the output values grow rapidly. Trigonometric function. 1. Definition. Trigonometric functions are functions based on trigonometric ratios like sine, cosine, tangent, etc. 2. Example, sin, x, and cos, x, are trigonometric functions. 2. They describe the relationships between angles and side lengths in right-angled triangles. Absolute value function. 1. Definition. An absolute value function is a function that takes the absolute value of the variable. 2. Example, x represents the absolute value function. 2. It always gives a positive output, regardless of the sign of x. Piecewise function. 1. Definition. A piecewise function is a function defined by multiple rules that apply to different intervals of the domain. 2. Example, f, x, equals x squared for x is greater than or equal to 0. F, x, equals x squared for x less than 0. This piecewise function behaves differently for positive and negative values of x. Logarithmic function. 1. Definition. A logarithmic function is the inverse of an exponential function, where the variable is the logarithm of a given base. 2. Example, Log base 2, x, is a logarithmic function. 2. It represents the power to which the base 2 must be raised to obtain x. These are just a few examples of the different types of functions. There are many other types of functions, and they play a crucial role in various mathematical and real-world applications. Functions allow us to model and understand complex relationships and patterns, making them fundamental tools in mathematics and beyond.